second of 3 videos that were designed to help you understand how to go from grams all the way over to particles, or from particles all the way over to moles. And what we had done before was dealt just with particles to moles, or grams to moles. And now we're going to find out how to go all the way from particles to grams, or grams to particles. So we have a couple of practice problems here to show you, or to review for you, how to go from moles to particles. When we're going from moles to particles, it doesn't matter what the atom is. And so what we're going to do is go ahead and calculate this top problem first. And because moles is sitting on the top of our first fraction right here, we want to have moles on the bottom over here. So we're going to have 1 mole down here. And we know that if this is 1 mole of gallium, that the number of particles of gallium that represents is 6.02 times 10 to the 23rd. And this is gallium atoms. So we've got that set up, and now when we do our actual calculation, we're going to find out, we'll divide the 5.2 by the multiply those two numbers. And as you get out your calculator to do that, you'll multiply the 5.2 times 6.02. Why don't you do that with me as I do it on the calculator? And that number is going to come out to 31.304. Now, as we look at the two numbers that are involved in that process, the 5.2 is only 2 sig figs, so that's all the sig figs we can have in our answer. And even though there's a lot of numbers on the calculator, we can only have 2 significant figures. So it comes out to 31, and then we also have to take into account this guy. Okay, that power of 10. So we're going to put that in over here, 10 to the 23rd. And that's going to be gallium atoms. Now we want to change this to scientific notation. So when we change it to scientific notation, we have to take the decimal from here to here. And so our real answer is going to come out to 3.1 times 10 to the 24th. And if you don't know how to do that, you need to go back and restudy my pen method, and that will get you through this kind of calculation. So that's your first one. The second one down here, we're going the opposite direction. And so we're going to take the fraction as it looked up here. We're going to take that fraction and we're going to turn it upside down. So here's the 6.02 times 10 to the 23rd atoms of gallium. And on the top, that gallium should have a lowercase a. Let's get that fixed. That's Ga. There we go. And then at the top, we should have the 1 mole of gallium atoms. Okay, and now as we do this, and we run the calculation, we're doing a division problem where we divide 8. Oops, I'm messing up on my calculator. 8.5 divided by 6.02. And the number I come up with on my calculator is 1.411960133. We don't want all that garbage. All we want is the number of sig figs that we need. And if you look right here at the 8.5, that's 2 sig figs. So that determines how many sig figs we have in our answer. And this becomes 1.4 times, now we've got to divide this number, that power of 10, by this power of 10. And to do that, we have to subtract exponents. And this comes out to 10 to the minus 3. And because this number is already in the right, has the decimal in the proper place for scientific notation, we don't have to change anything. And so there we've done our first calculation, and that are the first two calculations, which were moles into particles or particles into moles. Now, let's go over here and see if we can do these. I'm going to move a little quicker on this. We have on the left side here, and let's go ahead and get rid of our little shade and block out the other stuff so we don't have to think of that and just concentrate on this left side. This is what we did last evening. And last evening we came out with grams to moles, which you see right up here. Okay, grams to moles. These guys are going back and forth. And so in our first problem, which is right here, we're going to go ahead and get started and have our 14.2 grams of gallium, and we're going to convert that into moles. And to do that, we look at the periodic table. And in the periodic table, we see that gallium is 69.723. And that's grams of gallium. Notice we have to have the grams on the bottom of the fraction. On the top, we have 1 mole. And now we have to divide the 14.2 by the 69.723. And I got a syntax error because I punched stuff in wrong. 14.2 divided by 69.723. Okay. My number comes out to 0.2. Now I'm looking at my numbers. How many sig figs do I want? I want 3 because the 14.2 is right there with only 3 sig figs. So my calculator says 0.20 and then 3 6. Well, because the 6 is after the 3, we have to bump that 3 up to a 4. And that's it. If we get this in scientific notation, it becomes 2.04 times 10 to the 1 minus, or the minus 1. And that's how we would get the answer for this one, which would be in moles of gallium. And we should have had moles up here of gallium. And so that's all fixed up. So here's our answer for this guy. Now let's go to the second one, which is the reverse process. In the first one we were given grams, and this one down here we're given moles. So we've got the same substance. So the 69.723 grams of gallium is now going to be on top instead of on the bottom like it was up here. And the moles that were at the top in the first question is going to be on the bottom down here because we're going the opposite direction. And now we have a multiply problem, 7.51 times 69.723. And that's in grams. Our answer that we get on the calculator is 523.6. But how many sig figs do we have? We have 3 because this 7.51 only has 3 sig figs. So let's round this to 524 and make this in scientific notation. It would be 5.24 times 10 to the minus 2. And this is going to be grams of gallium. And of course I forgot to cancel these guys out. And that left us with this as the unit of measure for our answer. And here we go. That's it. We're going to do one more video now. So stay tuned. Talk to you in a little bit.